Not as long as Cal Evans. I think they actually had typewriters when Paul started at this. He'll give you a little bit of background into his experience. Paul's going to talk about dealing, like it when I got here, dealing with code that someone else wrote that you really want to kill for doing that. So I'm going to turn it over to Paul. Please welcome Paul and give him your attention.
So this is my first time spending a lot of time in Austin. I've been here for what, we got here yesterday?
Yeah.
Now? And just today I went down to 6th Street, Maggie Mae's, Iron Cactus. That's a nice, I like that area. Had me some scotch. Put this up here. I don't really like standing behind the podium if I can avoid it. I like walking around, so the guy on the camera may track me around a little bit. So again, this is, it was like that when I got here. Out of Modernizing, I can see Codebase. Actually, I'll just hit the forward button instead of the play button. So there's, before we really get started, anyone who's ever been to one of my talks before knows that I like to give book recommendations at the beginning. There's nothing that you're going to hear from me tonight that is more important than what these three books have to tell you. All three of these books informed this presentation, and you should read them. The first one is called Refactoring by a guy named Martin Fowler. This book is a dictionary or a catalog of tools, tips, and techniques on how to improve the quality of the code base that you're working with without changing the functionality of the code base that you're working with. The idea is if you've got a crappy little piece of code someplace, you need to improve it, this will give you some tips on how to improve it. The code base ends up working the same, but it's going to be easier to maintain afterwards. Very important book. The second one is called The Mythical Man Month. Who has heard of something called Brooks Law? 1, 2. This book was written in 1975. It is a collection of essays from the guy who worked on the IBM OS 360 project. Every single word he has to say from 1975, was that 45 years ago now? It's all still true. It all still completely applies. Just change the name of the language from COBOL to PHP, it's all the same thing. Brooks Law, and this is the central essay, states that if you have a software project that is running late, if you add more people to that project, it's going to become more late. Adding people to a project does not make it go faster. It makes it go slower, in fact. He talks about why that is. It comes down to a couple of reasons. We'll talk about a couple of those later. If you read this book, you will know more than any 3 project managers you've ever met in your whole life. It's a fantastic piece of work. The last one is called Clean Code. This is by Uncle Bob, Robert Martin. If refactoring is about the micro level of improving the code base, code is about the macro level of improving the code base. This is about getting your layers separated properly, making sure things are named properly, the overarching architecture of the system. That's what clean code is about. Again, another fantastic piece of work. That one informs this presentation as well. Any questions on these 3 books? So a little bit about me. Again, my name is Paul Jones. In a previous career, I was paid to be a spy. I worked for 8 years in Air Force Operations Intelligence. And I know that you're all thinking of your military intelligence jokes now. That's fine. I've been programming since 1983 in one capacity or another. So if anyone here born after 1984, congratulations, you win our prize. I've been doing this longer than you've been alive. Which is good and bad. It means I have a lot of old bad habits. I've been programming specifically in PHP since 1999. So that's what, 15 years now. In that period of time, I've been everything from a junior developer to a VP of engineering, done a lot of open source work. The most recent thing is the Aura project, which is a collection of fully decoupled, truly independent libraries. You download one, or install it by Composer. You just get that one library. None of the libraries have any dependencies on anything else. So if you're just trying to put something together on your own, or if you want to install just one piece and get just that one piece, check out the Aura project. It might be for you. I'm also the author of a relatively well-referenced benchmarking series on the overhead that's invoked when you call up different frameworks. So how Zen Framework 1 performs, how well Symfony performs, that kind of thing. And I know that Ralph and I have had discussions specifically about the Zen Framework performance. I was also the author of the original Zen Framework 1, some of the original Zen Framework 1 components, ZenDB, ZenView, that kind of thing. If you like them, anyone here use the Zen stuff at all? If you like those parts, you're welcome. If you don't like them, I'm going to say they broke them after I left, so don't blame me. I was an advisor on as far as community stuff, I was an advisor on the Zen Certification Advisory Board. I wrote some questions for that. I'm a voting member on the PHP Framework Interop group. I was the driving force behind getting PSR1, PSR2 coding standards out there. There's sort of a love-hate thing there, I understand. And the PSR4, the new improved autoloader standard, worked on that with Bo Simonson. And finally, this is the one I'm really interested in right now. It's called Action Domain Responder. This is some people are saying it's a replacement for, I'm calling it a refinement of Model View Controller, specifically for the web. And we can talk about that in more detail later. If you want to find out about that, just Google for Action Domain Responder. It's the first link that comes up. So what we're going to be talking about tonight is the crappy code base that you're stuck with at work right now. That's really not your fault. You inherited it from someone else. You've got to deal with it one way or another. We're going to talk about how to deal with it in an incremental fashion to reduce the technical debt that you have inherited. And then finally, we're going to talk about, okay, we've done these few low-hanging things. We've gotten some low-hanging fruit taken care of. Then there's still other things we would need to take care of afterwards. So part one, it was like that when I got here. You have just hired on at a brand new job. They love you. The project is already late. They've hired you on because they think you can help. They've given you a brand new laptop. You've got two 27-inch monitors. You've got your Aeron chair. Everything's golden. You sit down Monday, 9 o'clock. You check out the code base. You run compose. You get everything set up. 10 minutes later, you're clawing out your eyes because the code base is absolutely horrifying. There were a lot of things that he didn't tell you when you signed up. And one of them is about the spaghetti mess that you've got to deal with. It's what I will call a page-based, include-oriented system. And I can see some people smiling right now. You're really going to smile when we see the code example for this. You already know what this looks like. There's includes everywhere. Anytime you pull one include, it's actually pulling in a dozen other includes. Anytime you change one variable in one place, it actually has an effect over here. So anytime you fix a bug in one place, something else breaks. Because the includes have gone wrong, or globals are wrong, something like that. Global variables are everywhere. If you're lucky, you've got some sort of class structure there. There's maybe not that many, and they're scattered all over the code base, so you have to go searching for stuff every time you want to fix something. And then finally, there's no unit tests. If you're lucky, you've got a QA team that anytime you make a fix, you push it off, you push it up to the central repository, QA will check it. QA's actually got it worse than you do if this is your situation, because they're the ones stuck at the end of the process the whole time. So this is a terrible, terrible code base. You work there for a little while, and then you realize, we've really got to do something about this. It's taking me 2 weeks to fix something that should be fixed in 3 days. So you go to the boss. You say, hey boss, I really like working here. I want to help you, but I can't do my job well if the code base is going to stay this bad. We need to take a break for a moment. On our next sprint, just take 2 weeks, take some time to improve the code base, then everything will get better after that. The boss looks at you and says, I know the code base is bad. I'm sorry. The last 3 people we hired said exactly the same thing. But the project is late. We don't have time for this. What we need to be working on is fixing the bugs, adding the features. The people who pay our bills, whether it's investors or customers or whatever, they don't care about you being unhappy. They care that their stuff is getting taken care of. Our priority is not your quality of life. Our priority is making sure the business continues to run. You argue back and forth a little bit about, whether developers need to be happy or not, and how it's going to improve their productivity. But at the end of it, you want to be a good employee. You realize the boss has a totally good case. The business has to keep running. So you go back down, you sit at your desk, and you continue to suffer with the code base as it is. Then, because we're still behind on the project, a few weeks later, they hire on another developer. He comes in Monday morning, 9 o'clock, sits down at his laptop with his two 27-inch screens. 10 minutes later, you hear him screaming. He gets up, he walks out, he goes up to the boss. He comes back 15 minutes later, he's all dejected. He sits down, he looks at you, and he says, how did the code base get to be this bad? You look at him and you say, truthfully, I don't know how it got this bad. It was like that when I got here. This is not the situation we want to be in. There's a reason it is this way, and I'm going to assert that there are 2 reasons. They're both related to each other. And they both relate directly to PHP. The great thing about PHP is that anyone can use it. This means that if you're not a professional developer in the first place, and you've got an idea about a project that you want to run, something that you want to put together as a business, you don't necessarily need to know a lot about programming in order to get it done. You can sit down over a weekend, put together some code, put up some HTML, have it out there, maybe after the weekend, maybe the next week. Traffic starts coming through, you've got to process some credit card payments, and all of a sudden you're making money. And all of a sudden you've got to worry about scaling problems like that, but you're making cash, man. The thing's a great success. Then after a while you realize, maybe, the site's going down a little more often than it ought to, it's not scaling up as well as it should. So, great success, it works, turns into, it works. And the reason for that is the great thing about PHP is the same thing as the awful thing about PHP, and that is that anyone can use it. The people who write PHP programs that get really, they can write PHP programs that can become very popular very quickly without having known what they're doing. And the thing is, when you, as the professional person coming in to look at this code base, you're looking at it, and it's like looking at a dancing bear. The thing about a dancing bear is, when you're looking at it, you're not criticizing the fact that his pirouette is off balance. You're not concerned that his plié is not at full depth. You're just amazed the sucker is dancing at all. The code base is, how did this ever work? You're looking at, how did anyone ever get this to do anything? And again, the reason is, the guy who wrote it in the first place, he wasn't professional. He wasn't thinking about overall architectural patterns on anything. He wasn't thinking about long-term maintenance. He just wanted to get something done in a weekend. He certainly was not thinking about unit testing, regression testing, to make sure that bugs, that when they came up, we'd be able to track that something was wrong. The guy who wrote this, the person who wrote this, has also probably already moved on to his next idea. He wrote the program, he sold the company, and now you poor bastard, you're the one stuck maintaining it. And just so that we all understand what we're talking about here, we're going to look at a little code. So here we have, anyone see this? Yes, I see it. So let's just take a look at this for a minute. So we've got right here, we've got a bunch of required, so okay, cool. And we set a couple variables, all right, app equals type equals organization. Is that a bug? They're not. ID equals user $user. Where'd that come from? One of those includes, maybe. Where'd it get from? You have no idea. You have no clue. So let's go to owner name equals convert name. Well, there's function. Where'd that come from? I don't think it's a PHP function, is it? Well, let's go to the PHP manual. See if no, it's not there. We have to find the code base now. This is a real code base, by the way. I've changed the names to protect the guilty. $J equals how is $J equals $J?
Oh, wow.
Yeah, exactly. Fine. Sure. Just go on. So if user ID, there's some SQL right here in the page. Isn't that nice? Some right bar. Oh, and then we'll manipulate the SQL. That's also very nice. There's some HTML we're going to dump in a variable. All right, very cool. Header insert. Oh, look, CSS. And not just CSS, but CSS in a variable. Wait, I thought we were doing the header. No, now we're doing the header. Yeah, fine. More SQL. More SQL. More HTML in a variable. Echo user ID. Echo the beginning content into the intro content. More HTML. And echo the bottom text and include the footer. And exit. There's 2 pages here. The first one's wrapped in an if block. Look at all the rest of this. What's going on here? This is the kind of thing I'm talking about. Everyone here has had to deal with something like that in one capacity or another. Again, why is it this bad? Again, the original developer, we can't blame it. Everybody here has written that code before. If you say you haven't, you're lying. So we didn't know any better. And then the subsequent developers, when they came onto the project, it's better to leave it alone. We have no idea why it's working. Let's not mess with it. We'll just add on to a little bit. Add on to a little bit. We know it's bad, but you know what? It's not bad enough that we have to fix it now. We'll fix it later. Later's now. I mean, at some point, it's just not going to work for you anymore. So that's the situation we're in. There's actually a name for the situation. The name for the situation is technical debt. Who's heard this phrase before? Right on. That's your higher percentage than most people. For the rest of you, I won't do you the disservice to reading the slide. The thing you need to know is this. This is a short version. Technical debt is all the stuff that you should have done, but you did not do. More specifically, in order to fix it, it's not a localized fix. It's not a little piece that you can fix in one place. There are a series of changes you have to coordinate across the entire code base in order to fix one piece of debt. Does everyone get that? So this is not like refactoring per se in a localized place. You have to make a coordinated change across the whole system and then hope it works. That's technical debt. We've got to get rid of this. How do we get rid of technical debt? Well, it turns out that technical debt is a lot like financial debt. Let's think about financial debt for a second. You are a gamer, you want the newest console. The newest console costs $300. You do not have $3 in cash. But what you do have is a credit card. So you go to the store, you go to Amazon, you give them the credit card, they ship you the box, you get it, you don't have to pay anything. Well, you have to pay. You just don't pay right now. You get the stuff now, and then you pay the $300 over time, and you end up paying a little more than you would have if you paid cash in the first place, right? Same thing with a car. Buy a $30,000 car, you sign a loan, you pay it off for 4 years, and then you end up paying more than it would have been. Same thing with a house. $300,000 house, you sign a mortgage, pay it off for 30 years, costs you twice as much. But in every case, what happens is you get the stuff now. You get to enjoy it right now. You get to have the goodies. Pay for it later. That's exactly the situation we're in right now. We bought these features on credit. But you got to pay for it eventually. You got to pay this stuff off. That's technical debt. You got to pay it off in sort of a jump ahead. The problem with this is if it was up to us as the feature developers in the first place, we would much rather pay cash for a feature. Instead of getting it done in a week, cutting corners, getting out the door because of the deadline, we'd be much happier taking 2 weeks, maybe 3 weeks, planning it out, doing things right, making sure that it scales properly, and paying cash for the feature. But for legitimate business reasons, in many cases legitimate reasons, you have to bang it out now. You have to get it done to make the deadline. But in addition to that, the technical debt that you've got now is not the technical debt that you created. You have inherited someone else's debt. So it's not a question of paying cash anymore. You're stuck paying off the debt that other people have left behind, which kind of sucks. Really, it's all suffering anyway. You're suffering with the code now. So what you've got to do now is pick the kind of suffering that you're going to have. There's no easy way out of this. You're stuck with it. You can either leave it as it is and continue going on the way you have, dealing with it, being unhappy, grinding your teeth, and staying late, or you can choose a different kind of suffering, the kind of suffering that leads to growth. Talk about that in a moment. Right now we're all thinking, suffering, not only suffering, there's another way to deal with financial debt. That's bankruptcy. So I can just declare bankruptcy, all my debt's gone, I'm fine. The technical equivalent of this is the rewrite from scratch. We'll just seen aliens, right? We'll nuke the site from orbit, it's the only way to be sure. The thing about rewriting from scratch is that it feels really tempting. It's a really sexy idea. I can sit down, I know everything I've got to do, we've already got this existing system. All we need to do is copy it over, but do it right the first time. Very tempting thought. Doesn't sound like work at all, really. It sounds like a lot of fun. We can use the hottest new framework, we can use all the patterns that we've learned about, we don't have to suffer with all this old stuff. Like I said, it's tempting. I strongly urge you to resist this temptation. I want you to keep in mind at all times, whenever you're thinking about rewriting from scratch, remember Netscape. Remember what happened in Netscape? They were doing great, and they decided, we're going to rewrite our product. That was 97? They went out of business. IE took over, now they're Mozilla. Rewrite from scratch sounds great. The problem is that if you do a rewrite, you're going to be expending a lot of effort on the rewrite while not paying attention to the existing system. The existing system is the thing that's making you money right now. If you're expending effort on this other thing, your customers are going to leave you. Your investors are going to be unhappy. The bugs don't get fixed, the features don't get added. Either you don't add new customers, or the customers that you've got fall off, they go by the wayside, they go to a competitor. Now let's just say that you've got the time and the money to actually do this. You feel like, all right, we really do need to do the rewrite. Maybe we can figure out a way to maintain the old system and build the new system at the same time. Again, this sounds really tempting. So you hire a bunch of new developers. What do you do with them? Well, you can put the new developers clearly on the new project, right? We don't want them shackled by all the old ideas. You put the new developers on the new project, here's the problem. They don't know anything about the old system. They don't know anything about the business. They don't know anything about the problems you've run into. They don't know anything about operations. They're going to spend all their time talking to the old developers, which means the old developers are basically training the new developers and no one gets any work done. If you've got 4 devs and you add 4 more devs, how much more effort do you get? You don't get twice as much effort. If you're lucky, you get 20% less effort than you had before, which is counterintuitive, but it's completely true. This is straight out of the mythical man month. The problem is the communication costs that are involved. All right, fine. So we're not going to put the new developers on the new system. We're going to hire the new guys. We're going to put them on the old system, and they can fix the bugs, the features. And the new guys and the old guys who already know everything, they can start working on the new system. Same problem. The guys who come in still don't know anything about the system as it is, so they're going to spend all their time talking to new developers to figure out what the history on this bug is and why we did this particular fix. Same problem. You do not get a productivity increase from hiring more people in this way. Let's say you do it anyway. Let's say, all right, you know, I know it's going to take more time, it's going to cost us more money, that's fine, we've got the time to do it. Even if you think you've got the time to do it, it's going to take a lot longer than you think it is. I don't mean just a little bit longer, I mean a lot longer. We've all got a favorite estimation techniques. Everyone got a favorite estimation technique? Yeah?
Double it and then double it again.
Double and double again. Not bad. I got a better one. When it comes to this, you make your estimate, you double it, that's cool, maybe add some padding, but then you convert to the next higher units. So if you think it's a 4-week rewrite, it's really 8 months. I'm exaggerating, but only a little bit. It's going to take tons longer than you think it will. We are insufficiently pessimistic as developers about the complexity of the problems that we need to solve and about our ability to solve them. We're all naturally optimistic. It's a bad thing when it comes to this kind of stuff. So then, when you are in your 4-week iteration on the 8-month project, it's going to end up being 8 months, you're going to start cutting corners. It's taking too long. You're going to start taking shortcuts. And at the end of it, because you've heard your way through the rewrite, you're not going to have one bad architecture. You're going to have 2. The original one and the new one. This is not the plan you want to be working on. Any questions about any of this? Does everyone intuitively kind of get where I'm coming from here? The thing is, we are all, as developers, no developer ever looked at code and said, this is fine, it can stay the way it is. Ever. It's always a rewrite. Avoid the rewrite idea. What we want to do, instead of declare bankruptcy, is pursue an incremental approach to fixing this legacy code. This is the equivalent of paying off your smallest debt first on a credit card, and then paying off the next debt, paying off the one after that. And I know that in mathematical terms, that's not necessarily the right thing to do in terms of interest, but it is the right thing to do in terms of building momentum and raising your own spirits. We're depressed looking at legacy code. We need to find a way that will make us feel better about working on it and give us the energy to keep doing the next thing to make it better. Again, the problem with the legacy code is that technically it's bad enough, but we feel terrible when we're working on it. We want to improve our own mental state when we're working on it. What you do with the incremental approach is you make one small change. That's it. One change, make it across the entire code base, push, commit it, get it up there, they're working. And that's it. Then you make another small change. And another one. Over time, over weeks or months, these build on each other, and at the end of the process, you have a code base that is just infinitely better than it was, and it's still working the whole time. At no point have we had to take the developers off the primary project. You spend a day or two here and there doing a little bit of improvement, application keeps running, no one loses money, and it keeps going. Improve the quality of the code base over time. This does not sound sexy. This sounds like actual work, which is why no one wants to do it. So it sounds like actual work, but it has the benefit of actually working. As a side note, anyone recognize this graph on this picture on the side here? We've heard of the Agile model. We've heard of the waterfall management model. This is what's called the spiral model. This one is particularly well suited to risk management and risk mitigation. This is probably the kind of thing you're going to want to follow if you're going to do the incremental planning. This is, you can Google for spiral model. I've used it a few times. It's really very nice. So the incremental approach. The problem is, we feel terrible about the code. We feel completely overwhelmed by it. We have no idea what the first small change should be. If we knew what it was, we'd already be doing it, right? I'm here, and that's what the rest of the talk is about tonight. Is these are the small changes you need to make in this order to start making your life better. Our first goal when we're doing incremental changes is, of course, we need to keep the application running the whole time. If at any point the application breaks, we've missed goal 0. All developers would count from 0, right? We've missed goal 0. That's the one that we have to keep in mind all the time. Of the things that we are going to do while keeping the application running, the first thing that we're going to do is we're going to consolidate all of the classes that are in the system for auto-loading. Incidentally, we're also going to consolidate all the functions that are there. We'll talk about that momentarily. We're going to use something something called PSR0 for this. Again, I'll go into excruciating detail about that in a moment. The next thing we do is we're going to convert all of the globals in the system to injected dependencies. Again, I'll talk about this in some detail as well. But this is the mantra that I want you to remember. One small change. One thing. The smallest thing you can do. This is not your opportunity to say, well, while I'm making this change, I can do these other things too. No. One change. Resist the temptation to do other improvements. If you do multiple things at once and it breaks, you don't know which of the things you did that broke it. So one thing, one at a time. We then test it. Test is in quotes, I'll talk about that momentarily. You test it, you make sure the change works. You commit it, you push it up, push it to the central repo, send it off to QA if you've got a QA team. Test is in quotes for a reason. When we usually think of tests, we think of unit tests. If we had unit tests, we probably would not be in the position of having to deal with legacy code. When I say test here, I mean what are called characterization tests. The characterization test is sort of the black box version of a unit test. Unit test makes sure that a particular method or a particular set of code is working properly. A characterization test tests that the output of something is the same as it used to be. So you can set up Selenium, set up Codeception, something like that. For each thing you're gonna change, look at the HTML page for it, or the JSON output or whatever, get a copy of it, make your change, and then go back and run that same code again and see if you get the same output. That's a characterization test. The easiest way to do this is just eyeball testing. And frankly, that's generally what I have done in these. If you have the time and energy, characterization tests will save your butt along this path. But again, when I talk about testing here, it's characterization tests, not unit tests. Everyone get that? Okay. So, let's talk about the two big things we're going to do to improve this code base. The first one, it's all that classic autoloading. Who here knows what autoloading is? Excellent. Very good. So this you guys already know most of this. If you don't need to include the file anymore. If you just ask for the class, PHP, you give PHP a piece of code that knows where all of your classes are, converts the class name to a file name, and then loads the file for you so you can start getting rid of your include statements. The point of getting rid of these include statements, we'll talk about that again in a minute, is we want to see what the logical flow of the application is. If you've got a bunch of includes, you don't know which ones are executing logic and which ones are bringing in class definitions. It makes it harder to figure out what's going on. So what we're going to do is get these classes all auto-loaded, and then remove all the include and require statements that go along with those classes. That will begin to remove some of the cruft that's in there so you can see what's going on. I advocate the use of what's called PSR0. Familiar with PSR0, the old pair standard, Hort standard? Anyone not know what this is? Okay, that's fine. In short, what happens is the class name maps directly to the file name. So if you've got a class, exactly, you've already heard of it, you already know what it is, that's the formal name for it. And now under PSR0, there are a couple of tricks. Namespace separators in the namespace portion translate to directory separators. And because PSR0 came about at the time when we were transitioning from 5.2 to 5.3, 5.3 we got formal namespaces, we still honor underscores as directory separators in the class name portion. So notice that vendor package name, example name, package name in the namespace portion keeps its underscore, but example name in the class portion, the underscore gets converted to a directory separator. And so it's a little tricky. This is very nice for transitional purposes, especially if you've got a very old code base that has underscores in the class name. This is what the autocoding load looks like, or autocoding load. What the autoloading code looks like. If you want to talk about this in detail, we can. The short version is this converts the class name to the file path. And then, and this is the key, you see $base there close to the end? What we're going to do is we're going to put all of the classes in the system. They're scattered everywhere. We're going to put them all in the same base directory. So if you've got classes in 50 different places, they're all going to end up in one base directory, and then they're going to be in their own subdirectories from that, so that they're no longer mixed in with the rest of the code. Then you register it with SPL, and it becomes available. Now at this point, we haven't actually done anything. We've created an autoloader. We know the plan that we're going to go with. We've created a directory. Now we actually have to go through the code base and move the class files around. So what you do is, you can either grep the code base for remove class name, or you can grep the code base for include, whatever the class name is. When you find a class in the system, you find its file, you move it to our base directory location, and then the file, after you move it, you grep the entire code base for that class name, and you remove all the includes and requires that refer to that class name. Everyone got it? That's it. That's all you do. You do it for one class. Then what do we do?
Next one.
Test it. Then what?
Push it on.
Push it production. I award you no points, sir, and may God have mercy on you. Test it, commit it, push it, send it QA. One change, one class. Do it the next class, next class. Eventually, you run out of classes. That's it. Now, there are some caveats. If you have more than one, under PSR 0, it's one class per file. So if you have multiple classes in a file, split each class out to its own file. Name the file for its class name so that it works with PSR 0, and put it in your central classes directory. If you have page script, where a class is defined inline, mostly because that class is used only in that page script, extract the class, put it in its own file, put it in the class directory. And again, remove the includes requires as you go. There's one problem with this. Sometimes we will have execution paths that will have two classes with the same name, but they never conflict because the execution paths are different. So if you've got a class named user in one page and a class named user in another page, they never touch each other, that's fine right now. But if we're moving everything in the same place, we're going to have to change the name of one of them. That's fine. It's okay. If you change the name, just remember to grep the code base and change all the instances of that class name to the new class name. Everyone get this? That's it. One class. That's your one major change right there. Here's the thing. You do just that, you can leave the code base alone for a month now, if you feel like it. And it's gotten better already. One small debt has been paid already. Now, unfortunately, most of us are not dealing with class files most of the time. We're dealing with a lot of procedural code. Tons of function files everywhere. Anyone in this boat right now? A couple people, okay. The problem with autoloading is this: it doesn't work for functions. It only works for classes. There is a way around this. What you do is if you've got a bunch of functions, no matter where they are defined, you wrap them in classes as static methods on the class. Then the autoloading will work. So wrap the class as static for an instance method, move that class to the central classes directory, change all the calls, and again, we'll go through this point by point here in a moment. And then again, key is to remove the include and require statements that load up these function definition files, so that we can see more properly, so you can see more correctly what the flow of the logic is for the inputs. What this looks like is this. Let's say we've got this original function fetch results with global $DB. Well, that's just terrible. We'll deal with that later. All the function does is we've got results DB fetch, whatever query it is we're making, and then we return the results. And when we call it, it's just results equals fetch results, right? Simple, straightforward. The way you convert this is you wrap it in a class, we'll just call it example, because it's just an example. Public static function fetch results. Notice it's exactly the same code. All that's happened is we have put it in a method inside a class, and in this case we've changed the name so that it's PSR2 compliant. Not a big deal. You can leave this. Whatever your coding standards are, you can leave it according to your coding standards. Doesn't matter. The point is that we're going to wrap it in a class, we're going to make a static method, and then we say then we have to go back to the code base and change all of the calls that used to be just fetch underscore results to example double colon fetch results. Make the change, test it, commit it, push it, send it QA. Go on to your next set of function files. Now that's static method. I am required by the laws of professional programming to inform you that instance methods are the more proper way to do this. This is more complex, but I'm here to tell you it's going to save your butt later. Instead of making it a static method, you make it an instance method. And then when you go through to change the function calls, you add a new call above it to instantiate the object, and then you call the method on that object. Yes, this is literally twice as much code. It's 2 more lines, not 1 line. This is going to save your butt when it comes to testing later on. Questions on this? There's nothing, I want to be clear, there's nothing wrong with the static method. It's a perfectly fine place to start. I strongly suggest that if you can, you go directly to this, then the static method. Questions? That's it. Consolidating all your classes and incidentally all of your functions to a central location uses autoload. Questions on that section? Okay. So the next thing we're going to do is we're going to go to that collection of classes that we have just extracted, and we're going to take every use of globals in those classes, and we're going to convert them to injected dependencies. So to talk about this, we first have to talk about getting the dependencies into the class in the first place. This is a naive example. All we do here is if we've got this fetch results and we need a database connection in order to do our work, create a new database connection, pass the username, password, fetch, whatever, return. There's a lot wrong with this, obviously, not least of which is we're making a new connection each time we call fetch results. Not a good use of our resources. We can't reuse the connection. So if we need to make connection in 50 different places, we have to nicely make it in 50 different places. Finally, this is a big deal. If we ever change the credentials, we have to change the credentials 50 different places. Clearly this is bad. Nobody actually does this. They do it maybe once or twice and they realize there's got to be a better way. So they go out to the PHP manual and they, oh look, there's this global keyword. That means is I can create my database connection in a setup file that calls at the beginning of every script, create it, and then anytime I need it, I can say global DB and then use it. I can drag it in from the outside and it's available to me. Problem solved, right? Because now I'm sharing the connection, I can reuse it, and anytime I need to change the parameters, I just change them in place right there in the setup file, right? Problem with this, problem is this. You get what the quantum theory guys call spooky action at a distance. If you are sharing globals throughout the entire system, any modification to that global in one place affects it in the rest of the application. If you've got a global DB and someone is not careful and they unset DB inside a method, suddenly your database connection has disappeared and you don't know why. Good luck tracking that down. That's horrifying. Globals are not what we want to be doing, and there are different ways of doing globals, static properties, singletons. It's all the same. It's kind of the same idea. We're going to concentrate specifically on the word global here, but just realize that global state is the kind of thing that we want to get away from when we can. It causes a lot more trouble than it's worth. What we want to do is something called dependency injection as a result, or as an alternative. Who here has heard of dependency injection, DI containers, that kind of thing? Right? You guys are an advanced audience, seriously. It's really nice to see. The short version on dependency injection is that instead of starting within a method or within a particular scope, and then reaching outside of that scope to get what we want and drag it in, like we did with globals, instead of that, what we do is we start outside of the scope. We build all the dependencies that internal scope is going to need, and then we pass them into that scope. So the scope is not reaching out, the outside is pushing stuff in. Get that? Simple concept. In fact, what we're talking about here is the technique of dependency injection. There are entire pieces of software called dependency injection containers to manage that kind of thing for you. We are not there yet. We are just learning the technique and applying the technique across these classes that we have extracted. So by way of example, this is our starting point, where we've got global DB. We've got to work this in 2 steps. And in each step, you test it, commit it, push it, send it off to QA. This is the point at which it may be better to do a collection of things before you send them to QA. Otherwise, QA will hate you. They don't want like a million little changes. They want one big change. So we start here. First thing we do is we don't actually get rid of the global. What we do is we move it from the method that it's in up to the constructor. You begin to see now why I strongly recommend the use of instance methods rather than the static methods. If you've got a static system, there's no constructor to move to. So move the global to the constructor and retain it in a property. Change the original location to use the property. Step 1, test, commit, make sure it works. Everyone get that? Step 2 is we actually get rid of the global. Instead of having global $$DB and keeping it in a property, we move it to the constructor as a parameter of the constructor and continue to retain it in the property. What's the problem here? All the code that we're using now is broken because every time we create a new example, we now need to pass in a DB connection. So this means that after you make this change, you then have to go through the rest of the code base, find every instance of new example. Every instance of new example, create the database connection yourself or pull it out from the setup file, wherever it happened to be if you're in the global scope already, and pass in that database connection when you instantiate new example. Everyone get that? Then what do we do? Come on, you're killing me. Okay, someone, all right. So that's it. So we have to change all the instantiation patch dependencies. But there's a problem here. And that is, what if your dependencies have dependencies? Right? So you've got like 3 layers of classes and something way down here as a dependency. You can actually deal with this. What you have to do is pass the intermediary dependencies along the way. and then eventually work your way to getting those dependencies back out again. So this is another two-step process. Let's say that we've got a service object that needs the example object in order to fetch the results. And currently, the example object is using using a global. So you don't need, under this regime, you don't need to pass in the dependency at all. But we're changing fetch results to use dependency injection. So the problem is this. It's using dependency injection. What we need to do in the service class then, when it creates new example, you need to pass a database connection to the service object. So the service object can pass it when it creates new example. It's passing the intermediary dependency. Do this, test it, commit it, push it. This is step one. This is actually a violation of something called the law of Demeter. This is not our ending state. Our ending state is this. What we want to do is eliminate that intermediary dependency. What the service object actually needs is not a database connection. What it actually needs is an instance of that example object. So instead of creating new example in the action, we pass in a fully instantiated example object, retain it as a property, and then use it in the action. So this leaves us with the same problem. We still need to instantiate the database connection so we can pass it the example, instantiate the example so we can pass it the service. That looks like this. We started out with all globals all the time. Service equals new service. Isn't that easy? You have no idea what's going on here. How many database connections does that make? Doesn't need a database connection. What are its collaborations? How do you test this? You have no idea. You have to dig in through maybe 50 different classes to figure out what service needs. But it looks simple, right? It's terrible. The second version of the progression is we pass the intermediary dependency. So we create a database connection or we pull it out of our setup file or wherever it happens to be. Pass it to the service so the service can pass it to the example. But then finally, and this is where we want to end up with all dependency injection all the time. We create our new database connection, we pass it to the example when we create it, and we pass the example into the service. Now this looks complicated. This is literally 3 times as much code in the originating script. But look what you gain. You now know exactly what service needs. It needs an example. You know exactly what the example needs. It needs a database connection. You know exactly what the collaborations are. You know exactly how to set this up. And when you test it, if you set things up right, you can start passing in different kinds of objects to do different things depending on your testing system. So that database connection, for example, if you were creating that database connection inside something else, you've got no chance to mock that out or stub it out or make it something else. You know, you're hitting the production database with the production credentials. By doing it this way, you can pass in a completely fake object that doesn't actually touch anything, that feeds back only the data you give it. All sorts of advantages here. Everyone get what's going on there? So actually, there's a further problem with this. If you've got dependencies and dependencies and dependencies and dependencies, you're going to end up with a lot of code in your scripts to set up your objects. Believe it or not, that's fine. It's not a problem. We're going to be able to deal with that later on if we need to. The point of this is not to simplify the system per se. Our problem is not that things are not simple. Our problem is that we can't understand what's going on in the system. By doing this, we're making all these implicit information that's hidden inside classes. We're making it explicit. We're bringing it all up to the top so that we can see what's going on. So that's it. When you take them as a group, each step is kind of big because you've got a lot of things to work through each time. But the actual process on each step is very small. And you can do little increments on that through each one and then leave the code base alone. Each time you make one of those fixes, you can step away and code is better. That's the whole point. So we've done these 2 major reorganizational things. We've consolidated all of our classes and our functions into a single location so that we can use auto-loading. We've removed all the related include statements, so now we can see the flow of the application better. We've removed all of the globals in those classes in favor of dependency injection so that we can see what's going on. And we've kept it running the whole time. We've done it little bits at a time. There's no point at which, maybe you had to spend an hour or 2, 3 times a week at night doing this on your own time. Maybe that's the deal. Maybe the boss gave you a little time. The point is everything's still going. You're still making money. And you've paid off some technical debt. Now again, you've had to do some extra work. But your life is better now. The suffering that you've gone through is not the suffering of bearing a burden. It's the suffering of moving towards something better. In addition to that, just by moving all the classes to the same place, we now have an organizational structure for any new work that we do. We no longer need to leave things the way they were because we're scared to touch them. Anytime you need to add new methodology, add new functionality, or add a new group of stuff, you create a new class. You add a new method. You call it, and then you've got a way to start writing your unit tests against those classes. How many people actually have a unit test suite right now? Not enough. This guy's going to find you. Chris Hart just is, grumpy programmer. He's a big testing dude. Why do I mean big testing dude? I mean he's a big testing dude. He is going to be very unhappy if he finds out you don't have your tests. So write your test afterwards. That used to be where the talk ended. The problem is this. After the first 2 or 3 times I gave the talk, I thought it was great. Then like the third, fourth time I gave the talk, people started coming up to me afterwards saying, Paul, we've done it. We've moved all our classes, we've got our globals out. What do we do next? These are the things you have to do next. It's not a lot, but it's going to be long and tedious. You've probably still got a lot of new keyword stuff in your classes because they're not necessarily dependencies per se. You're actually creating stuff in there you can't inject from the outside. So you start realizing you need to have a way of handling new object creation. So you're going to start building some factories to deal with that. Then, once you've done that, you've written your tests against those factories, you're going to go back and you're going to look at all those page scripts. You're going to realize there's still all that SQL code in there. Okay, we'll just start pulling the SQL code out, putting in its own set of classes and methods. We'll build ourselves a gateway layer to deal with all of our data retrieval and storage. Then we're going to realize, okay, we've extracted the SQL statements, but we're still manipulating the data that we get back from those SQL statements in our page scripts. So now we need to take that data manipulation stuff out, all that domain logic, and put it in its own set of either a domain model or a series of transaction scripts or a service layer, pull all that out of the page scripts and move it off to its own layer of classes that are unit testable. Then we're going to realize, okay, we've got our action logic, we've got our object creation logic, we've got our action logic, we've got our presentation logic, still on the same file. Time to pull out the presentation logic, put that in its own separate response view layer. Then our page scripts are left. All they've got in is the action logic, and things are starting to look beautiful at this point, by the way. There's only 2 sets of things left in the page scripts. The object setup that we're doing for the dependency injection, and then the action logic that invokes those objects. All the presentation, all the SQL, the domain logic, it's all been separated out. So now we pull out the embedded action logic and put that in classes. And at this point, all our page script does is create objects and invoke the action. That's it. The problem is that the action logic we pulled out probably still has a bunch of include calls, so we're at the point at which we start removing all the remaining include calls that are in the system. We've gotten rid of a lot of them in these earlier processes. There's probably still going to be some stuff left over. This is the point at which you start extracting those. And then you realize the only thing your page scripts are still attached to file system. Remember, everything's still sitting in the document group. We browse to it directly. So now we're going to build ourselves a front controller with a router so that we can decouple the URLs from the file system so that we can start moving stuff around if we need to. And then finally, at the end of all of that, the only thing left in these page scripts that are now being routed to rather than being browsed to directly, all that's left in them is object creation logic. And our front controller is going to take care of invoking those objects for us. So at this point, at the end of all of this, all of the work we've been doing for dependency injection along the way, that's the only thing left. You pull all those out, you put them in you put them in a DI container as named services. Your router, your front controller, reads the URL, picks a service, hands off to it. Suddenly, you don't have page scripts anymore. Everything's in unit tested classes. Unfortunately, that is a lot of work. I can't talk about all that in a single presentation. So after getting enough of these questions, some people said you should write a book about it, so I did. This is the book. Modernizing Legacy Applications in PHP. Go to MLA PHP. You're starting out with a horrible spaghetti mess, and we've already talked about all that. By the end of this book, if you follow it, and again, it's step by step, everything that I've talked about tonight, in much greater detail than I've talked about tonight. All the regular expressions you need, all the things that have gone wrong for me anyway, everything about each step in the process, and all of those things isn't in here. So you start with a horrible spaghetti mess, you end up with something that is auto-loaded, dependency injected, unit tested, layer separated, front control. Now I'm not going to say this is going to solve all your problems for all time. What it is going to do is get you out of the horrible situation you're in with the low-quality problems of a low-quality code base, and you're going to trade up to the high-quality problems of a high-quality code base. You will note that. you would if you're going to pick your problems, you want to have high quality problems. Your issue is not going to be, why is my global here changing things over here? It's going to be, how should we refactor our domain model so we can have multiple data storage systems? That's where you want to be. Now, special deal for you guys, if you go to leanpub.com, crafting and pass in that coupon, go to that link at the bottom. And I'll put this up on the meetup, 10% off. It's cheap again.
Is that like first world coding problems?
First world coding problems, yeah. Unfortunately, most of us here are not living in the first world code. We're dealing with other people's stuff. Ladies and gentlemen, that's all I've got.
All right, thanks.